Good morning, pre-calculus. This is semester 2 APEX version, chapter 1. So we're going to start in on trig functions, starting with the most basic ones and our right triangles. So the first three that we are going to recall are sine, cosine, and tangent. So remember, I always like to circle my angle that I'm talking about. And then across from that is always my opposite. My adjacent is the one next to it. And my hypotenuse is always going to be across from my right angle, and it's also always my longest side. So the three main trig functions that we have are sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And remember, we can write that as SOHCAHTOA to remember it. All right, so let's go on ahead and let's take a look at using these. So it says find the three trig ratios for theta. I don't know why I have all this in there. All right, so we're going to start there. So I'm going to go on ahead and label this. So this is opposite, adjacent, and hypotenuse. So I'm going to go on ahead and start with sine. So sine of theta is opposite over hypotenuse. So it's going to be 15 over 39. And you could reduce it. I think they're both divisible by 3. So that would be 5 over 13. And I'm not too worried about if you reduce it or not, unless on a test if I tell you to. So you want to make sure you know how to reduce these. So then let's do cosine of theta. So cosine of theta is adjacent over hypotenuse, so that's going to be 36 over 39. Okay, and these are both divisible by 3 also, which gives you 12 over 13. And then tangent of theta. And that's going to be opposite over adjacent, so that's 15 over 36. Once again, these are both divisible by 3, so that's going to give me 5 over 13. All right, go on ahead and try the next one, and then see if you get the same thing as me. All right, so hopefully you've tried this already. I'm going to label mine. So sine of theta is 30 over 34. And both of these are divisible by 2, so that's going to be 15 over 17. Cosine of theta is adjacent over hypotenuse, so that's 16 over 34. Let's see, both of these are also divisible by 2, so that's going to be 8 over 17. And then tangent of theta is opposite over adjacent. So that's going to be 30 over 16, which we can simplify to 15 over 8. All right, so hopefully you remember that from both geometry and algebra 2. Now we're going to go on ahead and we're going to recall our 45, 45, 90 and our 30, 60, 90 triangles. Anytime we are dealing with trig and we have a 30, 60, 90 or a 45, 45, 90 triangle, we do not want any decimals in our answers, okay? We want them as exact as possible, which means that we want the radical version of them. So in a 45, 45, 90 triangle, recall that the two legs are the same length, and we're going to call them length m, and our hypotenuse is m times the square root of 2. In a 30, 60, 90 triangle, across from the 30 is always the shortest side, so it's m. The hypotenuse is always the longest side, so it's 2m. Okay? And m square roots of 3 is always the middle side across from the 60 degree. And these are going to come in over and over again because we're going to use these to solve. We're going to use these to develop our unit circle, which you guys have already seen, but we're going to do it again. And we're going to use it for just everything in trig that we do. So make sure you remember these. All right, so let's take a look at some problems using that. Okay, so I have a 90, I have a 60, so I know that this is 30. Okay, across from my 30 is always m. Across from my 60 is always m square roots of 3, and this is 2m. So it wants us to find the value of x, so we need to find that value right there. Well, we can't jump straight from here to here. First, we have to solve for m. So we say 100 equals 2m, because that's my formula for that side. We're going to solve, and we get 50 equals m. So that's this. However, I need to go on ahead and finish it. So it's going to be 50 square roots of 3. All right, let's go ahead and take a look at the next one. So here's my 30-degree angle. So across from that is m. Here's my right angle. So this is my hypotenuse. That's 2m. So I need to find x. So now I'm just going to take my 74 equals 2m and solve it. And I'm going to get 37. So that's all I needed to do on those ones. And there are going to be some that are a little more difficult, but these are some very basic ones. Okay, so let's go on ahead and take a look at my son's book report under there. All right, let's take a look at a couple of problems. So these ones are just using sine, cosine, and tangent. So it says a builder is constructing a wheelchair ramp. Okay. So there's my ramp. Okay. And it goes from the ground, so here's my ground, to a deck that is 18 inches high. The angle between the ground and the ramp must be 4.8 degrees. It says to the nearest inch, what is the distance between the end of the ramp and the deck? So it's not asking for the length of the deck for this hypotenuse here. Okay. It's asking for the length or the distance between here and here. Okay, so you need to really pay attention to what it's asking you to solve for. All right, so now I always figure out, okay, this is the angle I'm working with. This is my opposite, and this is my adjacent. So in order to solve this, I know my opposite. I'm looking for my adjacent. So I know I'm going to use tangent. My angle is 4.8 degrees. Okay, so tangent of 4.8 equals 18 over x, which is my adjacent. Okay, so now I'm just going to put that over 1 because I have to solve. Okay? So I have to get this x by itself, so I'm going to cross multiply, and I get x times tangent of 4.8 equals 18, and then to get the x completely by itself, I have to divide both sides by tangent of 4.8. Now, an important thing in your calculators, since this is pre-calc, remember last year, the last thing that we were doing in pre-calc was with angles, or in algebra 2, sorry, was doing trigonometry, and a lot of times we were in the radian mode. Make sure that you're in degrees mode and know that we are going to be switching back and forth a whole lot. Okay, so make sure that you are able to do that, and you know when as we start working through it. So I'm just going to do 18 divided by tangent of 4.8, and I get about 214 inches. It says round to the nearest inch. So 214 inches. All right, let's go on ahead and take a look at the next one. So the next one says a skateboard ramp will have a height of 12 inches. Okay, so there's my 12 inches. Okay. And the angle between the ramp and the ground will be 17 degrees. So that's going to be 17 degrees. It says to the nearest inch, what is the length of the ramp? Now it's asking for the length of the ramp. Okay. All right, so let's go on ahead and take a look at what we know and what we need. So I know my opposite and I need my hypotenuse. So I'm going to use sine of my angle measure equals my opposite over my hypotenuse, which is x. Okay, now if I cross multiply, if you do this enough, you'll notice that anytime this is in the numerator and this is in the denominator, those are just going to swap. So to solve this, I'm going to say x equals, and I'm just doing just what I did here, but I'm skipping a few steps. Okay, so solve it the way you need to. Okay, so that's just going to be 12 divided by sine of 17. So 12 divided by sine of 17 gives me 41. So X is approximately 41 inches. All right, let's take a look at another one. This one's a little bit more difficult. I know it might not seem like it yet, but let's go ahead and take a look. All right, so here is a park ranger, and he is looking at Old Faithful. Okay? So he's looking at the top of the geyser. So it talks about an angle of elevation. So remember, you have two angles that we've talked about. We've talked about angles of elevation. That's from a horizontal going up. And then you have an angle of depression, which is from a horizontal looking down. Okay, so remember those. All right, so here is my triangle. I'm looking at the top of an eruption of Old Faithful, or this park ranger, and the angle of elevation is 34.6 degrees. The ranger is standing 200 feet from the geyser's base, and we want to know the height of the eruption. So we want to know the total height from the ground. Okay. Well, we know that this is 5 feet because it says to his eyes is 5 feet. So we need to find this first, and I'm just going to call it O because it is opposite. All right, so let's go on ahead and write out this problem and solve it. Okay. So opposite, adjacent. So I'm going to use tangent. So tangent of 34.6 equals opposite over 200. Okay, so now I'm going to multiply, right, because I have to solve for O. So I'm going to multiply both sides by 200. And I get 200 times tangent 34.6. Remember that if you put tangent first in your calculator, okay, so if you do tangent of 34.6, okay, you have to make sure you close that parenthesis after the angle measure. Okay, if I don't close my parenthesis, so my answer here should be about 138. Okay, but if I don't close my parenthesis, I'm going to get the way wrong answer. Okay. All right, so this value is 138, but I have to add my 5 to it, and I get about 143 feet high. All right, so that was a quick reminder on sine, cosine, tangent, 45, 45, 90, and 30, 60, 90 triangles, and then a couple of word problems. We're also going to remind you about our 6 reciprocal trig functions. So remember reciprocal, right? So if I have 1 over 3, the reciprocal of that is where I flip that fraction. Okay? So I'm going to have cosecant, secant, and cotangent, and those are my 3 reciprocal functions. And you can see here, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. The way I like to remember this is there's this S in the middle of cosecant. Okay, so I remember, oh, that S there means it's the reciprocal of sine. Okay, so we're going to actually do a couple of problems so that you guys can see how they work. And then you're going to have a worksheet later that's going to have you do quite a bit more with those. And once again, keep in mind, if it is a 30, 60, 90, or 45, 45, 90 triangle, I do not want any decimals. It has to be in radical form, has to be in exact form. All right, so we're going to go on ahead here. Okay, there's my theta. So this is my opposite and this is my adjacent. Oh no, I don't have a hypotenuse, so I can't do this problem, right? Wrong. This is a right triangle. So remember, there's this old guy named Pythagoras who came up with the Pythagorean formula. Okay, so 14 squared, so 1 leg squared, plus my other leg squared equals my hypotenuse squared. So I believe that's going to be 2,500, just because I've done this before. No, I didn't just do that in my head. All right, so that's going to be 50. 50. And I can do 2 things. I can either start it like this, or I can go on ahead and simplify these. So I know that every single one of these is divisible by 2. So that would be a 7, a 24, and a 25 triangle. And if you remember any of your Pythagorean triples, this is a Pythagorean triple. Okay, so a Pythagorean triple are right triangles that we know the side lengths of. Like anytime I see a triangle that has a leg of 3 and a leg of 4, I automatically know that the hypotenuse is 5, okay, because it's one of our Pythagorean triples. If you don't remember that, that's fine. Okay? You can always find it by using your Pythagorean theorem. Okay. All right, so let's go ahead and find sine, cosine, and tangent. So we're going to start with those three. So sine is going to be opposite over hypotenuse. So that's going to be 24 over 25. And I've already got it reduced, so I don't have to do anything more. Cosine is going to be adjacent over hypotenuse. So that's going to be 7 over 25. And then tangent is opposite over adjacent. So that's 24 over 7. Now I'm going to do my cosecant, my secant, and my cotangent. So cosecant, I'm just going to flip this, just take the reciprocal, 25 over 24. Okay, this one right here, flip it, 25 over 7, and tangent to cotangent is going to be 7 over 24. Oops, sorry. All right, let's go ahead and take a look at the next one. So this one I could do the same thing. I can divide them if I already know what they're divisible by. So 18 and 80 are both divisible by 2. That leaves me with 9 and 40. Okay. So just going to make my life a little bit easier, pre-simplifying it. So now I'm going to do 9 squared plus 40 squared equals, and I'm going to take the square root of that, and I'm going to get 41 as my hypotenuse. So that's what I'm going to use because I'm going to use my simplified ones, but the hypotenuse actually was double that, so it was 82. Because remember, I divided everything by 2. All right, so let's start out the same way. Let's do our sine, our cosine, and our tangent. Okay, so sine is opposite, adjacent, hypotenuse, opposite over hypotenuse, so it's going to be 40 over 41. Cosine, adjacent over hypotenuse, it's going to be 9 over 41. And then tangent is going to be opposite over adjacent, so that's going to be 40 over 9. Okay. And then for my other 3, I'm just going to switch those. So cosecant of theta is going to be 41 over 40. Secant of theta is the reciprocal of my cosine, so it's going to be 41 over 9. And cotangent of theta is the reciprocal of my tangent, so it's going to be 9 over 40. And so we didn't have any radicals in this, but you are going to have radicals on your worksheet. So just remember, if you have something like 2 square roots of 3 and you need to square it, you have to do that squared to both of those. So that would actually be 2 squared, which is 4, and the square roots of 3 squared, which is 3. And so your answer would be 12. Okay? Or if you have something like 49 over 9, right? And you're taking the square root, you have to square root both the top and the bottom. So that would be 7 over 3. Okay, so remember those basic algebra rules, because on your worksheet today or on your assignment, if you're in class anyways, you are going to be seeing a lot of that. Okay. All right, so let's take a look at the last bit of this. Okay, so the first one says triangles whose corresponding angles are equals and whose lengths of corresponding sides are proportional. Okay, so angles are equal, sides are proportional. Those are going to be similar triangles. Triangles that have equal corresponding angles and equal corresponding side lengths are congruent. And then the common ratio of the 3 corresponding sides of 2 similar triangles. Okay, so this is the ratio that you get of similarity. Okay, you call it the aspect ratio, the similarity ratio. Okay, so aspect ratio. Sometimes you'll see it called ratio of similarity or similarity ratio. All right, so we're going to start looking at some angles based on our 30, 60, 90 triangles. And the reason I put this at the end instead of at the beginning there is because this is really going to start building on our unit circle which we're going to be working on as we progress. So when we're building our unit circle consists of a radius of 1. So knowing that, okay, that 1 equals 2m, okay, in a 30, 60, 90 triangle, we know that m then is going to equal 1/2, and our 60 degree, across from our 60 degree, is m times the square roots of 3. Okay, so that's going to be square roots of 3 over 2. Okay. So now we're going to have to use that. So we're going to ignore this 45-degree column for right now, and we're just going to deal with our 30s and our 60s. All right, so let's do just the 30-degree angles first. So sine of 30 degrees. Okay, so that's going to be 1/2. So our opposite over our hypotenuse over 1 is just 1/2. Okay, cosine is going to be square roots of 3 over 2 all over 1. Tangent, this is where it starts getting a little bit more difficult. So tangent is going to be our opposite, 1/2. So tangent is going to be 1/2 over square roots of 3 over 2. But remember, we never divide by a fraction, we multiply by the reciprocal instead. Okay, so if that's the case, then that becomes times 2 over square roots of 3. Okay, well, those 2's are going to cancel. So I'm with 1 over square roots of 3. All right, this is where it starts getting hairy. Remember now that we never leave a radical in the denominator. So to get rid of that, we have to rationalize the denominator by multiplying by a form of 1. Okay, and that's going to give us the square root of 3 over 3. All right, and as you guys do this, you'll get a whole lot better at rationalizing these denominators because we're going to be doing it so frequently. All right, so cosecant is just the opposite or the reciprocal of sine, so it's 2 over 1 or 2. Secant is the reciprocal of cosine, so you have 2 over square roots of 3. But there again, I have a denominator of square roots of 3, so I need to multiply. Okay, so I'm going to wind up with 2 square roots of 3 all over 3. And then my cotangent is going to be my tangent flipped. So that's going to be 3 over square roots of 3. Or I could come back here and I could start here and I could say, well, it's square roots of 3 over 2 over 1/2, which really means times 2 over 1, which just gives me my square roots of 3. All right, let's go ahead and take a look at our 60-degree angle now. All right, so here's my 60-degree angle. So my sine of 60 is going to be square roots of 3 over 2 over 1. My cosine is going to be 1/2 over 1. Are you noticing a pattern here? Okay, they're swapping. My tangent is going to be square roots of 3 over 2 over 1/2, okay, which was our cotangent before. Okay. So now we're going to go on ahead and we're going to do our cosecant, secant, cotangent. Okay. So our cosecant is going to be 2 over square roots of 3, but it's going to be flipped. So, oh, look, it's the same as our secant of 30 degrees was. So 2 square roots of 3 over 3. And then our cotangent is going to be the same as our tangent was. Okay, so once you figure out these formulas, it gets a whole lot easier. Oh, and I wrote that in the wrong spot. And I skipped this one. So my cosecant here is my secant of 60. Okay. All right, so now let's take a look at our 45, 45, 90 triangle. Same thing, so in a unit circle, our hypotenuse is 1. That means this side length is 1/2, and this side length is not 1/2. Okay, it's not divided by 2. That's 1 equals m times the square roots of 2. So that means that that's going to be 1 divided by the square roots of 2 equals m. But I got to rationalize this denominator. Okay, so I'm going to multiply by square roots of 2 over square roots of 2. So 1, see, we'll walk you through it. So times the square roots of 2 over square roots of 2. So that's going to be the square root of 2 over 2. So square root of 2 over 2. All right, so now you notice there's only one column here because it doesn't matter which angle I'm going from. The sines and cosines are always the same. All right, so we'll say here opposite, adjacent, and hypotenuse. All right, so our sine is going to be opposite over hypotenuse, so that's going to be square roots of 2 over 2. My cosine is the same, square roots of 2 over 2. My tangent is my opposite over my adjacent. Well, since opposite is square root of 2 over 2, adjacent is square root of 2 over 2, it's going to be square root of 2 over 2 divided by square root of 2 over 2, which is 1. Okay, so now let's look at our cosecant. So our cosecant is our sine flipped. So now we're going to have to deal with rationalizing in denominator again. Okay, so we're going to say 2 over the square roots of 2, multiplied by the square roots of 2 over square roots of 2. So I'm going to get 2 square roots of 2 over 2, which is just going to leave me with the square roots of 2. My secant is going to be the same, and my cotangent is also just 1. All right, so going ahead and make sure that you remember this, especially your 45, 45, 90, and 30, 60, 90 triangles. And I will see you next time.